In this video, we're going to talk about what happens when we change physical state. So when you move from a solid to a liquid or a liquid to a gas, is there energy coming into that system to make that happen, or is energy leaving the system to make that happen? And in order to do well with this, you need to know some vocabulary. You need to know what endothermic and exothermic are, you need to know what the physical states of matter are, and you need to have some familiarity with the kinetic molecular theory of matter. So if you haven't watched those videos yet, take a moment, take care of that before you start this one. So the basic question that we're asking when we address boiling or melting or freezing is whether those particles in the substance are moving closer together, i.e. I've got a particle here and a particle here. Are they coming closer together to, let's say, make a solid together, moving together? In which case, we're really wanting to check how attracted are they to each other. How attracted are they? Because if you're really attracted to another molecule, then you would want to snuggle up. Versus, are they starting close together and moving farther apart? So, if they're moving apart, then we have to ask, how are we going to overcome the attractions that they have to each other? Okay. Whoops. Oh, I shouldn't have written right across the middle of that. Let me erase there so you can see. So, when molecules in a liquid become a solid, do those particles come closer together or move farther apart? And it looks like I should have addressed boiling in my first one as well. So let's start with boiling. If I'm moving from a liquid to a gas, are my particles getting more spacious or are they condensing? Well, we know from the kinetic molecular theory of matter that my liquid going to a gas, that my particles are moving farther apart. So when I boil, we're moving farther apart. On the other hand, when we freeze, a liquid becomes a solid. In that case, the particles are moving closer together. So we want to ask, is energy coming into the system when we make these changes, or is it going out? So if I have to move those molecules farther apart, I'm having to put energy in to overcome the attractions to each other. So in the case of boiling, and you can think about it, you have to heat a pot up to boil. So you have to put energy in to make this process happen. When we put energy into something, that is an endothermic process. On the other hand, when you freeze something, you're really trying to take heat or energy away from your substance. And so in that case, you're asking the heat to leave, to exit. And so when we freeze something, you are losing energy from your system. And so that gives us an exothermic process. So let's look at a few changes of physical state and talk about whether they are endothermic or exothermic. If I'm evaporating something, am I asking my molecules to come closer together or farther apart? Well, I'm asking them to come farther apart, which means I have to put energy in to make that process happen, and that is endothermic. Melting is similar. I'm starting with a solid, particles are close together, I'm asking it to go to a liquid, the particles are farther apart, so that is also endothermic. Boiling, we just talked about, is endothermic. Sublimation, I am starting with a solid, excuse me, and going to a gas, and so I'm also asking my particles to move farther apart, and that will also be endothermic. Freezing, we just discussed. This will be exothermic. let's just for the heck of it throw in number 6 and do deposition. Deposition is the opposite of sublimation. So in this case, I am going from a gas to a solid. And when that happens, I am asking my system to lose energy, and so this will be an exothermic process.